Hi. Have you ever had your pipes freeze? Well, I'm from Alaska, and just about every real Alaskan has had his or her pipes freeze at some point in their life. And I've always wondered why hot water pipes freeze sometimes before cold water pipes do. This seems counterintuitive to me, but in this presentation I'm going to explain how it is possible. The research that I've done suggests that hot water can freeze before cold water due to a process called the Mpemba Effect, the increased kinetic energy of hot water and the rate of cooling, and the lack of dissolved gases in hot water over cold water. So the 3 points that I'm going to make are that the Mpemba effect can be observed when hot water that creates hot water freezing before cold water, that the kinetic energy in hot water actually makes it cool off faster than cold water, and the third thing is that when cold water and hot water reach the freezing point, the hot water will form ice faster because it has fewer dissolved gases in it. So the first point that I'm going to make is about the Mpemba effect. Dr. Brownridge from the American Journal of Physics indicates that the Mpemba effect was named in the 1960s after a Tanzanian student who brought to his class's attention the fact that ice cream can cool off faster when it's been heated first. He was laughed at until his professor went home and confirmed these results. And Dr. Hefner from Foundations of Physics shows that this problem, this observed effect, has been around for a long, long time. It goes back to Aristotle, Descartes, Francis Bacon. They all have observed that sometimes hot water freezes before cold water. The second point is that hot water cools more rapidly than cold water. Dr. Brownridge also states that the energy loss is proportional to the difference in temperature between two things. So we have this hot water sample in a freezer and a cold water sample in a freezer. The difference in temperature of the hot water is much greater, and so it cools at a much greater rate. It has to catch up to the cold water and then pass it to freeze faster. So Dr. Hefner shows that the eddy currents created in the convection keep going once they've reached the same temperature, and so this allows the hot water to pass the cold water in a sense and freeze first. The third point is that once they've reached 0 degrees, the hot water can form ice before the cold water, and this is because it has a lower dissolved gas content. Zumdahl states in my high school chemistry book that warm water holds less dissolved gas than cold water. If you've ever had a warm soda, you can tell that it's not fizzy, and if you ever drink a cold soda, it's nice and effervescent. And Joseph Thomas from Physics Reports shows that dissolved gas inhibits ice growth, so that it's harder for cold water to freeze once it reaches 0 degrees Celsius. I'm going to illustrate this Mpemba effect with this graph. We have a graph of 3 separate water samples, and it's a graph of temperature over a time period. And we can see that this first sample, which starts off at 58 degrees Celsius, cools very rapidly and actually catches up with the cold sample after only about 3 minutes. The middle sample, which starts at about 37 degrees Celsius, catches up to the cold sample a little quicker after about 2 minutes. And when they hit this plateau here, this is the water turning into ice. And so when it drops off again, that's when we actually have ice formation. So we can see that the hottest water sample freezes first, followed by the next hottest, and then way down here we have the cold water sample, which freezes almost an hour and a half after the hottest water sample. So to summarize, the research that I've done indicates that the hot water can freeze before cold water because of a process called the Mpemba effect, because of the increased kinetic energy and heat transfer of the hot water, and because of the lack of dissolved gases in the hot water sample. Just because a Tanzanian student was thinking why his ice cream cooled off faster when it was heated, we now have a better thermodynamic understanding of how water freezes, and you now understand why hot water pipes can freeze before cold water pipes. Are there any questions? Yes?
Will hot water always freeze first?
That's a good question. The short answer is no. We can't predict yet whether it will. Nikola Bregovich, who published a recent paper, states that the fact that this effect is not fully resolved to this day was an indication to me that fundamental problems lie underneath it. He's saying that we need to do more research to be able to predict. Next question.
Is the rate at which the hot water cools ever slower than the rate at which the cold water cools?
No. in order for the Mpemba effect to be observed, the hot water has to always be cooling faster than the cold water. Hefner states that rapid cooling must continue even when the initially hot water has reached the same temperature as the initially cold water. Next question.
Is the Mpemba effect still observed when the hot water starts at a very high temperature?
Yes. There was a paper published by Dr. Brownridge where he shows that these results suggest that it should be possible to observe 100 degrees Celsius water freezing before 0 degree water. So basically boiling water can catch up to and freeze before water that is at 0 degrees Celsius. Thank you.